lecture on one of the most significant hazard, or we can say widespread long-lasting hazard called drought. Drought hazard, which is not directly affecting the lives and property, but its impact is felt widespread. That is why it causes huge and unbearable loss. Drought, from viewpoint of definition, it is a part of Earth's climate. So whenever there is an imbalance with respect to the demand and supply of water in a region, then you can say it is a drought. And this is a drought, which is a kind of phenomena that occurs every part of the world. It does not recognize cultural, political, or regional differences. I mean to say, it can affect Afghanistan, Pakistan, Bangladesh, India, and Sri Lanka. If you see statistics, drought is the kind of hazard which has affected more than 45% of people, those which are affected by various disasters. That means almost half of the people affected mainly because of drought only. Why? Because drought is a kind of phenomena which is a slow poison, creeping hazard, and develop cumulatively. By the time we understand that there is a drought on the ground, it becomes too late. So we need to think from different angle that how to check, how to monitor a drought. So during drought events, you will find its impact is vast and diverse. Particularly if you see India, India is a country with the huge landmass, and it is mainly the population. More than 70% of population depends on agriculture. It has got vast rain-fed area and dryland area. More than almost 50% of area is under rain-fed. So you can India, one or another part, experience drought on one and another year. So during drought, you will find there are different kind of impact like that: drying of land, cracks develop, no germination of the seedlings. You will find also unemployment because there is no job opportunity, cattle starvation, death, distress sale of cattle. There is a shortage of fodder, shortage of food for the cattle, and mainly for the women. There is drinking water shortage, reduction in the crop and crop performance, crop production. Finally, it affects the food security. So drought is directly linked to the food security, nutritional security, as well as you can say overall well-being of the region. Now, if you see, drought has got different kind of occurrence across India. Mainly Western India, which is highly prone to drought, Gujarat, Rajasthan. But these days, we are experiencing consecutive drought in Bundelkhand region also. There are droughts in the Marathwada and Tamil Nadu. Even recently, 16, 17, 18 also. If you see, there are hilly state, mainly hilly state like Uttarakhand and even Assam, northeastern state also experience drought. So you can say it is mainly the climate variability, and recently whatever the few observation or record of climate change, that is mainly leading to the shift of the drought belt to the flood prone area and flood prone area becoming drought. So intensity of drought is increasing over a period of time. Even those hilly states which never experienced drought. Mainly they experience flood or some other kind of disaster. Now they are also witnessing drought kind of phenomena or drought hazard. So green revolution happened in early 60, late 60 and early 70s, and which has brought quantum jump in the production. But whatever we have achieved through this technological effort, drought is a kind of hazard which cancel out all the benefit what you can achieve with the development of technology. So we have to develop a kind of strategy, or we have to think about drought, how to reduce the drought, how to manage and risk reduction strategy has to be developed to counteract the effect of drought. So totally, if you see in developing countries like India, economical, physical, and social effect will be there. They are mainly in totality it result into a famine kind of condition. Or finally, if drought is persist for a longer period of time, then you will see there is a complete abandonment of the geographical region. So whenever a drought is there, you will see situation like this, where okay, in India, this is a one picture taken in 2002, drought in Rajasthan. Whenever there was a drought in 2002, there were people at well, not or at hell. So you will find queue of women, or women has to walk this kilometer and kilometer distance to fetch one baltin or one water, gada of water. So you can see this kind of situation even for drinking purpose. People have to struggle a lot whenever there is an acute or severe drought. Because 2002 was the second worst most drought hit, followed by 1987. 1987 was the significant and the most worst drought hit in India. So if you see the definition, drought, as I said, it is natural and recurrent feature of the climate. So because climate system, whenever there is an imbalance in the climate system, it mainly causes the drought. So drought should not be viewed simply as a physical phenomena or natural event. Its impact is on society from interplay between the natural event as well, like less precipitation and then the result expected rainfall. It also caused by the delay in disturbance in the ocean atmospheric circulation. You people must have heard about ISO phenomena, El Nino Southern Oscillation. Whenever there is a ISO heat, El Nino heat, you will experience, a region will experience drought. And whenever there is La Nino phenomena, then the region will experience flood. So, but in a country like India, in this current century, there is a close linkage is being established between the El Nino event and the drought frequency. So drought is directly linked to the El Nino. That is why ISO can be a good indicator of drought forecasting in tropical countries like India. So simplest way, water scarcity with reference to given demand in a specific region called drought. Now we'll see here different kind of drought. There are different definitions being put up forward by the various scientific experts. So meteorological drought, in layman term, if we say it is a lack of rainfall. Whenever there is no rainfall, you can say it is a drought. Scientifically, drought is defined as a degree of dryness in comparison to some normal or average amount of rainfall during a prolonged dry period. Or another way you can say it is a period of prolonged dry weather condition on the ground. So whenever rainfall in a particular region is less than climatologically expected rainfall, or climatologically normal rainfall, then you can say there is a meteorological drought. And meteorological drought affected by temperature, humidity, less cloud cover, humidity, all these affect the meteorological drought. Then there is also agriculture drought. Now agriculture drought, when it comes to agriculture, it is mainly directly related with the crop and the soil moisture. So agriculture drought occurs when moisture in the root zone is inadequate or less to meet the water requirement of crops. That is why agriculture drought is governed by the relative leaf area index and relative availability of water in the soil. Means soil factor, soil moisture, soil texture, soil porosity, and also ground cover, canopy cover, all is most important to determine the how to what extent water requirement of crops can be met. So it has not much thing to do with the meteorological drought. Third is the hydrological drought. Hydrological drought mainly associated with the effect of period of precipitation. It is mainly associated with the effects of period of precipitation or shortfall on surface and subsurface water supply. That means whenever there is a drying of surface and subsurface water resources, you can say there is a agriculture drought. So in this graph, you can understand meteorological drought, then agriculture drought, soil water deficiency, plant reduced canopy cover, then hydrological drought means reduced stream flow, groundwater table decline, the drying of lakes, ponds, and reservoirs. Fourth is a socioeconomic drought. Socioeconomic drought occurs when demand for an economic good exceeds supply as a result of weather-related shortfall in the water supply. Means whenever there is a less economic good services like recreational facility, decline in the tourism activity, ranching by the rancher, all these are the economic good services. When these kind of activity services are not scanty or reduced, then you can say there is a socio-economic drought. So if you see with respect to drought, but Gujarat is one of the most vulnerable state to the drought over the last century. So in last century, last one decade of the last century, you can see Gujarat has experienced almost 6 drought. But all India level, there is no drought. This shows that Western India, particularly Gujarat and Rajasthan, which experience maximum number of drought, not only because of less rainfall, but it is also because of high aridity and high degree of evaporative demand of the atmosphere. Now you see historically different kind of drought status in India. So if you see in the current century, beginning from 2001, 2002, as I said, 2002 was the most significant drought hit in India in the current century. But in last century, there were the first worst most hit of the drought is 1987. Current century it is a 2002. 2002 year is a worst most drought hit, followed by 2009, then 2014 and also 2012. So 2002, 2009, 12 and 14. These are the, and 15 also. 14, 15 mainly, you will find, you see here how drought pattern has changed. 14, 15, you are seeing here, Marathwada is experiencing drought. 14, 15. And also 13, some Tamil Nadu, 13, some Tamil Nadu, and then 12, Karnataka. So drought is becoming more widespread over the period of time in the current century, and those regions which were highly vulnerable to drought like Gujarat, Rajasthan are becoming less vulnerable, and those regions which are flood prone are becoming more vulnerable to the drought because of climate change. Now 17-18 also you can say 17 that was 60% India received less rainfall. So Gujarat and this year you can see, I can give you an example. 2017 very above rainfall is there. There was no drought. The rest of the India was experiencing drought. That Western India was not having any drought in 2017. So this kind of situation now changing with respect to the partial pattern of drought. Drought assessment, that all about the drought definition, the category of drought, and what are its occurrence. Now, drought assessment. Conventionally, there is one every hazard monitoring, assessment, and early warning. So the government of India has mandated one nodal agency to collect database, and monitor and do early warning for the particular hazard. So for drought, India Meteorological Department is a nodal agency that forecast, that also monitor drought based on conventional or traditional aspect like traditional weather database like rainfall, temperature, or certain drought index. So most common percentile normal method is one of the most common method. According to this method, a season is termed as drought when seasonal rainfall received over an area is less than 75% of its long-term average. That means if rainfall is received is less than 75% of normal, then you can say there is a slight drought. If this rainfall deficit is between 26 to 50%, and then you can say it is a moderate drought. If this deficit exceeds 50% of normal, then you can say it is a severe drought. Then we have another method which IMD adopt for dynamic, or you can say weekly based drought monitoring, that is a aridity index. So aridity index is nothing but potential evapotranspiration minus actual evapotranspiration divided by potential evapotranspiration. For this method, one needs subdivisional scale, actual weekly time series of rainfall, and actual weekly time series of potential evapotranspiration. So for computation of aridity, you need at least rainfall data, weekly rainfall data, weekly temperature, and the soil water capacity, available soil water capacity, is soil map. Then you can run water balance model for every subdivision, and you can come out with the actual evapotranspiration. Then you can categorize using aridity index: arid, mild arid, moderate arid, and severe arid. Either arid or you can say drought classes. If negative is there, then you can say it is a no drought. If aridity anomaly is between less than 25%, then you can say it's a mild drought. If negative anomaly is positive anomaly is 26 to 50%, then it is a moderate drought. If positive anomaly is greater than 50%, then you can say it is a severe drought or severe arid. So these are the different kind of drought indices. Aridity we have seen, it measures the deviation in actual rainfall, evaporation from the potential state. IMD mainly uses this monitoring for a subdivisional scale. But there are other drought indices also, like Palmer Drought Severity Index. This is same, it requires also rainfall and temperature and available water capacity. But this index is widely useful for particularly USA, United States of America is mainly using this kind of index. Why? Why India is not adopting Palmer Drought Severity Index? Because we don't have enough station network which can have the ability to measure temperature. We have station, India Meteorological Department has established very good network, but there are, in comparison to the developed countries, we don't have enough network with the sophisticated instrument that measure wind speed, or we don't have A-class observatory, enough number of A-class observatory. So which can provide the information about temperature which is required for computing Palmer Drought Severity Index. That is why India and Asia mainly implement index for monitoring drought is a standardized precipitation index. This index is good to depict dry and wet spell at multiple time scale. It is simple and popular to detect meteorological drought. Fourth is a crop moisture index. It is a measure between the actual and the potential evapotranspiration. Crop moisture index is different from the standardized precipitation index. Mainly, it measures difference between the actual evapotranspiration and climatologically expected actual evapotranspiration. So, this is the index which is directly related to the agricultural drought because it gives you information about short-term fluctuation in soil moisture storage, which is purely required for the assessing the agriculture drought. That is why crop moisture index is ideally suitable for real-time, short-term agriculture drought monitoring. So here we see, okay, one widely accepted index is a standardized precipitation index. This index you can compute for multiple time scale or different period. Time scale may be 1 month, 2 months, 3 months, up to 48-month time scale. And for 1 month from every period, January, February, a different period, you can get different time scale SPI. SPI is similar like Z-score, but here before computing Z-score, you need to feed a gamma distribution to observe value, then transform back to the normal distribution with mean 0 and variance 1. So once you get the standardized index, you can get 1, 2, 3 months of given month represent the standardized deviation in the precipitation of same month and precipitation total of same plus previous 2 months. That means 3-month SPI of any month represents standardized deviation in the of same month, precipitation of same month, and the precipitation total of same plus previous 2 months respectively. Positive value of SPI indicate there is a no drought. Negative value indicate there is a less precipitation or drought. So if we see applicability 1 to 3 month drought time scale drought, 1 to 3 months time scale SPI is useful for short term drought monitoring, and then 3 to 6 and month it is good for the seasonal drought. 9 and 12 months indicate good for the precipitation pattern and water resource assessment. 24 and 48 month time scale is maybe good for climate change studies. Now here you can see there are some episode of drought for 1982 September month SPI. These are all x-axis is the number of station, 160 station. Y-axis is the SPI value. Now 1982, if you see, most of the station has got SPI between 0 to -1. That you can say most of the Gujarat, all parts of Gujarat were under the slight drought because index is between 0 to -1. Next is a 1987. As I said earlier, 1987 was the most significant worst drought hit in the history of India, which you can see from here. You see, all stations in 1987 were having a SPI index between -1 to -2.5. That means all stations were having negative, and that too with the more severe. So moderate to severe drought was there across the whole India, even part of whole Gujarat. Then third is a 1988. Always El Nino followed by La Nino. This is our evidence from this. 1987 was the worst drought hit because of El Nino phenomena. Next was the 1988 was the above normal precipitation and flood-like situation. Now you see here, most of the stations having a rainfall between 0.5 to 2. Most of the stations okay having 1 to 2.0 SPI value. That means above normal precipitation was there. Then fourth is a 1997. You see most of the stations between 0.5 to -0.5. This is the 1997 was the best example for the normal year. Now you see this, okay, 1987 geostatistically interpolated SPI value, partial pattern of 3-month SPI, August, all is okay yellow. That means whole Gujarat was under drought. Second September also it was under drought. October also it was under drought. All negative. But next year all positive. All months were under above normal condition. So SPI is one of the good indicator for monitoring drought. Now we see, okay, how on India level, as I said, if causative factor for agriculture drought is deficient rainfall, soil moisture, rise in temperature, and rise in water demand. The effect will be the of drought is a reduced crop sown area, poor germination, loss of crop yield. India Meteorological Department monitor aridity index as well as person rainfall. Then how state declared drought, that is based on rainfall, crop sown area, delay in sowing, some ground observation, reservoir level, manually observe agriculture situation. These are the conventional observation and data which are being used for declaring drought. What is the problem with this conventional system? That is a sparse observation. As I said, we don't have enough network of observatory to monitor drought. Sparse observation. There's sharp variability in weather. India is a big country. India has got large degree of variability with respect to land use, climate regime, soil, and terrain. To capture the variability, we need to have a very dense network. But we don't have. So we cannot capture climate or weather observation correctly, representativeness with representativeness over whole India. Then physical nature of parameter. All these temperature, vapor pressure deficit, or rainfall, all are physical parameters. So they don't have direct linkage with the agriculture performance, crop growth, development. So for that you require certain biophysical parameter also. And another, all these observations are non-partial. They are not graded data. And so also manual subjectivity. Accuracy of observation varies from observer to observer. Inconsistency with respect to data collection and availability of data in real time mode. Because there are different states, they adopt different kind of data collection, protocol, then data delivery and data quality, all is has to be verified. So it takes time, and for the dot, suppose you want to get some data, it may not be available to you for real-time dot monitoring, because this all verification, all this takes time. No uniform criteria adopted for dot monitoring across different states, because depending upon the kind of data available with the state. Here state is the node agency. nodal agency to declare drought. Drought declaration is done by state. It is a state business. So different state has got different kind of criteria. But now central government has implemented a new drought monitoring policy and come out with the new drought manual and ask all states to implement the new drought manual based on the remote sensing as well as conventional observation. Now, why? This is the lacuna. Space observation, we don't have enough observation. We don't have enough other important observation. So the reliability of this all meteorological drought indices is highly questionable, particularly region with space distributed weather network. That is why we need to have a combination of monitoring tools like remote sensing and weather information in an integrated manner for generating a drought map. So here I want to make you understand that how satellite works to detect any aberration or any deviation in crop performance because of drought or sensing drought. So first, you see here whenever there is a rainfall occur, what happens? Some part of this rainfall infiltrate into the soil. Some part of it is lost as overland flow. Some part is stored as a soil moisture. Once it is stored in the soil moisture, it is being taken up by the roots. It moves to the plant leaves. From leaves, stomata, it exists, and one molecule of CO2, carbon dioxide, get fixed through photosynthesis. Once this photoaccumulate produce, it leads to the increase in biomass. New leaves are formed. Once these new leaves are formed, then only once these new leaves are formed, then this satellite sensor is detecting. But here rainfall that occurs almost 2 or 3 weeks back, it is detected by satellite remote sensing after 2 or 3 weeks. That is a vegetation index, optical satellite data. So optical satellite data like NDVI, which has got time lag associated with the drought monitoring. But nowadays, new sensors are being developed with passive microwave sensing or active microwave sensing, which can give directly information about soil moisture. What we need for monitoring agriculture drought? Fluctuation in the soil moisture storage. So if we could able to monitor on a weekly basis in real-time mode changes in the soil moisture storage and impacted crop condition with any sensor, then we can surely monitor agriculture drought for the certain practical application. Like here, with the understanding of response of remote sensing, this is a one curve, how this electromagnetic radiation, different kind of spectral band response is there. So if it is a stress vegetation, particularly in the visible range, you will find there is a increase in reflectors because there is no chlorophyll. Chlorophyll absorption will not be there, so reflectors will be more invisible. If it is healthy crop, chlorophyll concentration is more, so it absorbs the photosynthetically active radiation, is visible light. In NIR, whenever healthy cell wall is there, healthy crop is there, and it has got a healthy cell wall, so there will be more NIR scattering. But if there is a drought stress, cell wall get ruptured, so NIR region, NIR wavelength cannot be scattered. This scattering will be less. So finally, reflectors will be less. Further, reflectors in the short wave infrared band, that is a 3 water absorption band, 1.4, 1.9, and 2.4. Here, because of presence of water in the leaves, short wave infrared wavelength is being absorbed in these 3 wavelengths. So whenever there is a healthy crop, more absorption will be there. Whenever there is a drought stress, more reflectors will be there in the short wave infrared wavelength. So using these different kind of bands, one can construct different kind of remotely sensed indices like NDVI, SAVI, normalized difference water index, short wave infrared water stress index, land surface wetness index. Both vegetation as well as wetness indices can be generated for monitoring drought. There are different kind of sensors that are being developed which are useful, like India has got resource set 2, which has got advanced Swift payload available, which provides image, optical image almost weekly, almost in 5 days. So you can have monitoring of vegetation, drought impacted vegetation regularly. Then also we have certain reset or some data for some mapping kind of satellite high resolution. But there is also ocean set, which is having ocean color monitor. Ocean color monitor based images can be converted into a NDVI image, which can be also useful for the monitoring drought over a region, whole India or a state. Then also we have certain weather related satellite like INSAT, which can provide information about insect 3D, which provide information about temperature, some wind speed, rainfall, and also we have solar radiation. Some passive sensors are also there, which has got ability to provide information on the rainfall. So what I mean to say, India have capability to monitor drought for whole India, as well as high resolution mode for state level, block level, as well as district level. Drought monitoring can be possible with the sort of kind of sensor available in orbit. So Earth observation has got multi-task capability, meteorological observation, emergency communication satellites are there. You can have connect with the mobile application, then SMS alert. Then there are also LEO real-time mapping also can be possible. All weather mapping is also possible, along with the Doppler weather radar and AWS. All you can integrate to derive disaster support activity, particularly with respect to the drought. Now, especially for drought monitoring, there are different kind of satellite data which are being widely or commonly used. Are NOAA, which is a US NASA-based satellite, Terra Modis, that is also operating for last 10 to almost 20 years. This is almost more than 30 years. Then we have our IIRS sweeps and advanced sweeps. These all are having a capability to monitor drought. Now we have also OCM that also some capability to provide vegetation index for drought monitoring. So how this drought can be monitored, particularly with remote sensing data. Satellite remote sensing, because of its synoptic viewing capability, it provides images of large area coverage, and also it is frequently available observation. It can help you to timely detection of drought, timely detection as well as monitoring of drought for more prompt availability of spatiotemporal data, so you can make some informed decision making related to the drought management aspect. Since drought stress affect directly to agriculture, so any index which is most closely related to evapotranspiration or soil moisture is a better index for the drought. So as I said earlier, normalized difference vegetation index, this is the most commonly used for monitoring drought. It can assess, it can enable to detect drought impacted vegetation. It cannot directly give you information about drought condition, drought status, and also it is not giving you much information about real-time drought monitoring, because of there is a time lag associated with the rainfall. As I said, rainfall occurs 2 weeks back, but we can able to monitor after 2 weeks only, or able to detect drought only after 2 weeks. So there is some kind of time lag response associated with the optical satellite data. But even though there are certain sensor like so if you have optical satellite, but having short wave infrared band like advanced beams, if we construct NDWI as short wave infrared water stress index, then it can better sensitive to the short term fluctuation in the crop with water status and can be better for the good humid condition. So it is better. We can detect changes in the soil moisture well in advance compared to the NDVI. Third is the vegetation condition index, because vegetation condition index it is entirely based on the NDVI, but you require to have a historical database of NDVI. Here why? Because there are different kind of crops which has got different sensitivity to the drought. So if we are monitoring drought and comparing drought across the scale, partial scale or region, then we need to standardize the sensitivity of different vegetation type or geographical differences in the sensitivity of vegetation type to the drought. So if we have historical data, we can do standardization or normalization of NDVI and make index which is more specific for the comparison of drought across the partial scale. The fourth is a vegetation temperature drought index. Here, not only NDVI or NDWI, here you are integrating vegetation index along with the temperature, land surface temperature information, because both has got negative relationship. That negative relationship is being exploited to derive index called vegetation temperature condition index, and this is the index which is much more related with the soil moisture and evapotranspiration. So in India, particularly standardized criteria for operational drought assessment is there. In India, we have large scale development, technological development has happened over the last 1 decade. We could able to acquire infrastructure for monitoring rainfall. Modernization of IMD has and there are too much deployment of the AWS observation for monitoring weather condition. Geostationary satellite data available which provides hourly image for the about weather condition. Then for soil moisture, now we are running with the soil water balance model with the good soil information and weather observation, automatic weather station. We have now microwave based rainfall estimation, microwave satellite data based rainfall estimation and soil moisture estimation, which are being used for the drought. Thermal based data also to certain helps to detect evapotranspiration as well as soil moisture condition. Then crop condition, mainly the optical satellite data which provides almost daily satellite image of NDVI or other indices to generate biophysical variable also. We can monitor crop condition. We can develop also certain kind of crop loss detection models due to drought, and finally improve the survey of crop production. Crop zone area also possible by certain kind of indices, satellite observation like slope sanation angle index, SASI, developed by the NRSC. We could able to identify crop zone areas also. Also with the NDVI, frequent monitoring with the NDVI, we can also develop generate how much area is sown under the different kind of crops. After integrating crop zone area, crop condition, crop anomaly, soil moisture anomaly, and rainfall anomaly, we can develop certain drought declaration protocol. Now you see, under National Agriculture Drought Assessment and Monitoring System, what are the data being used? As on today, there is a resource set NDVI, NDWI, NOHR NDVI, ocean set OCM NDVI, Terra Modis also SASI and NDWI, Terra MSRE that is for soil moisture, INSES CCD, NDVI, all were being used to support agriculture drought assessment in India. So for drought declaration with the remote sensing data, mainly what has been used: relative deviation in the rainfall, VCI, in-season transformation, and finally extent of NDI anomaly, rainfall anomaly, and sown area deviation is used to declare the drought, whether mild, moderate, or severe. And also drought warning for June, July, and August, normal, watch, and alert is given for the almost 30 state bulletin agriculture drought categories for the district level. For 13 state agriculture drought bulletin is issued under this NADMAS methodology. So here you can see agriculture drought June, July, August, September, October. So every district, okay, it is categorized into mild drought, moderate drought, severe drought. Then okay, this okay, all category bulletins is issued to the different district or state level for the different district level drought categories. Now with the advanced data, some Andhra Pradesh or Haryana, some under NADMAS block level statistics is also generated. Showing progress is also given. You see, these are some old map, but it is still okay. Mahalanobis National Crop Forecast Center. Earlier it was done by the NRSC. Now we have mandated agency or mandated center, institutionalization of center like Mahalanobis National Crop Forecast Center. They are mandated to provide monthly bulletin of the agriculture drought assessment with the same methodology. Other indicator is a VCI. As I said, for VCI we require historical data, historical NDVI data. Like NDVI is nothing but NDVI of a particular year which we want to assess for particular week or month. NDVI means absolute minimum NDVI of a particular week or month in a historical years. Similarly, absolute maximum for particular week in a historical data set. So after getting okay NDVI maximum minimum from historical data set for particular pixel level, we can compute VCI. Similarly, TCI, brightness temperature from NOAA data supports thermal based infrared. You can convert into a brightness temperature, then apply same methodology to compute the temperature condition index. Then both combining vegetation condition index and temperature condition index, we can generate vegetation health product. Like here you see 2002, as I said, one of the most significant drought hit. So you see all these are red patches. This is all are under the drought. But same date, July 21, in previous year, it was no drought. Then again, August 2002, same day, there was a large portion under drought. But on the same day in the previous year, there was no drought. So this is one of the good index, vegetation health product, VT. That is one of the good real product derived from the remote sensing data to assess drought. Like okay, as I said also NDVI anomaly from 1987 with the NOAA kind of data now available for 37 years. You can see the worst drought hit. You see whole India, majority of India were yellow. That is means negative NDVI anomaly. So you can say that was all drought year. More than 441 districts were affected in 1987. All month were under drought. So latest 2002, you see it was the significant drought, bad crop year. This is a 490 NDVI data set from NOAA. you can see easily you can capture that drought year, which has got the lowest values of the NDVI throughout the growing season. So here these are the okay. In Rajasthan also you can see 2002 all month were under drought. This yellow negative NDVI anomaly, but 2001 you can see it is all positive. So no drought. Here it is a 2000. It is a first 2 months were under drought. Slight drought were there. Then 2003 all are above normal. So you can categorize different areas with the mild, moderate, severe, or slight drought categories, and also assess the crop performance. Now you see here, okay, same NDVI anomaly we translated into a seasonal vegetation index anomaly, integrated over season and related against the crop departure or crop yield anomaly. Now you see here, this kind of seasonal vegetation anomaly is a good indicator of any crop loss or detect the loss in the food grain associated with the drought. So food grain anomaly is directly related with the seasonal vegetation anomaly index derived from the satellite data. So we can better use this kind of index to foresee what would be the impact of the drought on the crop loss of food grain loss in particular district or particular state. So another index, okay, as I said, temperature vegetation condition index. Also for Gujarat, also you can here you require to generate trapezoid between the LST and the NDVI. After exploiting this trapezoid, warm age and cold age, you can generate vegetation temperature condition index. So here you can see we could able to generate this VTCI and related it with the crop moisture index, because our aim was to monitor short-term fluctuation in the crop moisture index. So here VTCI was found very good related with the crop moisture index, and so we can see better monitoring of the drought. So here you see 2002, 2001, 2 and this 2004. 2004 was a normal year. This is one of the significant drought year, a slight drought year. Same here you also capture drought duration from the same VTCI after thresholding with the less than 0.45 is a drought. Greater than 0.45 there is a no drought. So any wall pixel which having a less than 0.45 in different time period, we have named it as a drought duration. So you see drought duration period are very high in case of 2002 compared to 2000 followed by 2000, but 2003 and 2001 near normal condition. The same drought duration was highly related with the groundnut yield in Saurashtra in Gujarat. So this kind of satellite based indices can be useful for drought monitoring as well as crop loss detection, even for prediction of the groundnut yield in certain specific dominant areas. Another index also globally FAO mainly implementing, that is a water requirement satisfaction index. Here also you can derive length of growing season directly from the satellite data, rainfall from directly satellite data. Then you can run water balance technique, develop of water requirement satisfaction index. So water requirement satisfaction index is potential indicator of drought early warning. So here you can see again 2002. Okay, sorghum, maize, and pearl millet. So in 2002, all production were for all three millet crops was less compared to the 1998. And same you can see in the WRIC index. Okay, you can see here 2002 all very poor condition, or the crop is a poor condition or crop is a in bad condition. But in 1998, it is a good crop or very good crop condition. So this all modeling also can be done with the satellite remote sensing, and we can generate partially water requirement satisfaction index for monitoring agriculture drought. Same vegetation index also were tried earlier for Saurashtra, Gujarat, and related with the soil moisture, crop moisture index. You can see here also weekly base Saurashtra. So 2002 all yellow, red, that is means all drought. 2003 green means all Saurashtra, all district area were under normal condition. Same Eastern Rajasthan also 2002 or red or yellow, that means all stress based on the VCI, and here but 2003 normal, so all green. Another for Bundelkhand also, not only VCI or not only rainfall, meteorological index. Nowadays, new trend is that we need to use combined index, like spatial vegetation drought index, combining meteorological and remotely sensed index to better monitor the agriculture drought. So we have developed one new index which can efficiently monitoring the drought in Bundelkhand region. Similarly, like if you see globally, there are US adopt different 5 criteria like India. India uses new sown area, soil moisture anomaly, rainfall, vegetation condition. But in US, they use CPC-based soil moisture, farmer drought severity index, SPI, and satellite-based vegetation health condition for monitoring drought. Now there is a new index also developed in US, which is called vegetation drought response index. Till today, every country we are relying more on satellite-based monitoring of drought along with the weather-based observation. But now third dimension is taken into account, that is a biophysical component, means socioeconomic data, land use, land cover, soil, sensitivity of vegetation to drought, deep or water body, recharge pond, all available physical factors are incorporated to derive the drought. So this which is giving better aspect, because some area may be having a irrigation facility which cannot be captured while deciding the drought. So if you have all those biophysical and socioeconomic data integrated with while monitoring drought, we can better capture the drought status on the ground. So modeling approaches are also being developed to derive the drought and desertification index and any related loss in the crop yield. So drought prediction also can be possible if we integrate regional climate model, simulated output along with the crop model to forecast the crop loss, and finally the drought forecast. And such kind of information can be passed on to the users, farmers, through SMS or alert service. So there is always a possibility to predict drought and assess, develop a decision support system which can be helpful to the farmer for their irrigation and moisture services. Various drought early warning system globally available. So one of these is a Patel as well NADMAS. Globally, it is a FUSE, USA famine early warning system is there also. So these all are working for global, regional, and national initiative. So here, this is all about drought aspect. Now I like to have certain